Okay, see, I told once again what is a counter. Counter is a basic application of flip-flop. Okay, now a counter, as the name suggests, we should know, as the name suggests, counter is a digital device which can count something. Basically, counter are one of the simplest type of sequential network of a digital electronics, and counter is usually constructed from one or more flip-flops that change output accordingly the input pulse are received. That means what? That means it can count the input pulses. See here, we give a clock from the input and it can count the how much a clock are received. Okay, now the counter are basically, we can classify it with some three categories. One is asynchronous and synchronous counter, second is single and multi-mode counter, and third is modulus counter. Now in below, see the block diagram. There it is a 3-bit and we use for 3 flip-flop to storing the 3-bit. Now all are the T flip-flop. See, the output is Q and Q bar is given and input is the T. Now my question is that the T is, all the T is connected with the VCC. I asked you the question, why the all T are connected to the VCC. Srinivas, why? Tell. What is your answer? Why those all the T's are connected to the VCC? Good, Moa. Good. Nice. No idea. Okay, Srinivas, just remember yesterday class, the last class, where I told this T flip-flop is introduced in market because of the using the useful purpose of JK flip-flop, that is toggle. We know the JK flip-flop output, if the J and K is 1, both are 1, then output will be toggle. Toggle means if the previous state was 0, then the present state will be 1. It will toggle, and previous state, if previous state was 1, then previous state will be 0. Remember something? Now for introducing these, we introduce the T flip-flop, that means the toggle flip-flop, which is like that, J, K and Q, Q bar. So this J and K are short circuited like that way, and it will be the T. Now whatever input is given here, that input is fed to also J and K. So by T there is a two possible, one is 0 and another is 1. If we give T is equal to 0, then what happen? The both the J and K will receive 0 0. Am I right? Then if J and K will 0 0, then the answer will be no change, NC. So it has any use for us? Whatever previous state was, that remain indefinite time. So in application of counter, the 0 0 is not used. We need 1 1 because toggle every time. Why? Why toggle? What is the use? See, count. This is 1, 2, 3, 4. Okay. Now in binary, 0 0 0 1 1 0, then 1 1. Am I right? See here, 1, sorry, I did mistake. That is 0. Sorry. Big mistake. 0, 1, 2, 3. Okay. Now see, from 0 to 1, wait, I just delete that. 0, 1, 2, 3. Okay. Now see, the 0 to 1, the 1, this stage, this bit portion, B0 portion bit is only toggled 0 to 1. See. Now, for the next case, when 2, see, it is also toggle, it is also toggle. Now for the next case, that is toggled. Is it clear? So just only toggling the bit, we can count a decimal number equivalent. Like if we want to count 0, then our bit storage should be 00. Now if you want to store 1 as a decimal, then it should be 01. In that purpose, what happened? This is the B0, and suppose this is B0 bit and this is B1 bit. Now see, this B0 bit is toggled. Am I right? Is it clear or not? Rahul? Okay. Now if we want to count the 2, then what happen? It should be 1 0, then both case 1, it is also toggled. From previous stage to next stage, it is also toggled 1 to 0. Is it right? So in that way, we can see, just toggling the previous output from next output, we can count. Okay, that is why we use T flip-flop here, and all the T are connected to VCC for providing the 1. Because we know if T get 1, then J and K get 1, and the toggle mode is activated. Now for every clock pulses, the flip-flop will toggle. Is it clear? Now why this T flip-flop are used and why this VCC connected to the T? Is it clear to all? Okay. Now see. Now check the operation. Now in that case, T got 1, T got 1, T got 1. Now see, it is bubble here. What does it mean? If the bubble is present here, that means it is the negative clock pulse. We will activate this negative triggering flip-flop. Okay. Now this clock is running like that way. Sorry, that way. Now when the negative pulse is getting not, means Rahul, what is your problem? Tell. This not. Oh, yeah. Okay, it is that means it is a negative clock triggered. Okay, that means the negative portion of clock, when it get, then it will work. Okay, now see, for that, hello, are you hearing me? Can you hear me? Okay. Actually, there is very network problem. Okay, no problem. See, when the negative clock pulse is arrive here, then suppose first we clear the all output and all are 0. Okay. Now when the first clock is hit, then what happen? What will be our answer? When the first clock is hit, the suppose it is 1, it is 2, it is 3. Okay. Now suppose it is D3, D2 and D1. Okay. Now for first clock, when it hit, if it stored 0, the first case all are 0 because we reset all the flip flop. Now the first clock is arrived, then the output of one flip flop is toggled. Am I right or not? So it will be then 0, 0, 1. See, this portion is toggled. Am I right? Why those two are not toggled? Because this one is fitted with that and the output of that will fitted with that. Q0, Q1, Q2. So when the first clock is hit, the output is changed to 1 but it will act in 0 because it is negative trigger. That is why this was not triggered. And if this was not triggered, then there is no possibility to trigger that one also because the output of Q2 T2 will trigger the T3. The output of T1 trigger the T2. In that way, in that sequence, we connect this circuit. So in first case, when the first clock is arrived, the output is toggled to 0 to 1 for T1. But if this output is fed to the next flip flop, but we know the not is there, that is why it is only work on 0, but here now output is 1, that is why the T2 is not working. Is it clear? That is why the rest of all flip flop are zeros. Is it clear to all? Why? Mua? Okay. Now imagine in next clock. What happened? In next clock pulse, this 1 now toggle to 0 again. And when this 0 come to this, it will 1 now. Am I right now? Okay. Now, for next clock pulse, what happened? This 0 will turn in 1, but when this 1 is arrived, it will, the T2 will not triggered because it will negative triggered, so it remains same. Now in next clock pulse, it will triggered like that 1 0 0. In that way, the counter is count. Is it clear to all how the counter count? See cinema, see here. What I saw, you just see here. Actually, my net piece is very dangerous. See, in first case, Srinivas, output was 0. The clock is arrived and it will work in negative clock pulse. That means when the clock is 0, then this flip flop will work. That is why the NOT is here in every clock. Is it shown? That means when the clock receives 0, then the flip flop will triggered. Is it shown? That is why the bubble here. Every clock got bubble because it's shown that it is the negative triggered. Is it shown, Srinivas? Have you any problem on that? What I told, that it is a negative triggered. Okay, I just told you that every clock shows a NOT before the clock. That means the clock, or you may say the flip flop, will triggered when the 0 is come. Is it clear now? If this T1 get 0, then the output will toggled because all the T got 1 from the VCC. Now only one controlling device is the clock. When T1 got 0 clock, then the output will toggle. So suppose in first case we got 0 clock and the output of T1 flip flop will change 0 to 1, toggled. But in that case, when the output of T1 got 1, see, this output is fed to the next clock, next flip flop's clock. Now tell me, this flip flop will work or not? Because here now 1. Is it work? Why? I already told this clock, all clock are negative trigger. That means when it receives 0, then only it work. So now, in first case, when the output is toggled to 0 to 1, this 1 is now fed here. Now that flip flop 2 is worked or not? Is it worked, Srinivas? One toggle, but another condition is it get clock. When the clock get 0, that time it will the toggled. Because in flip flop, this is the difference between a flip flop and latch. I already told. A flip flop has a external clock, and with this clock the output will change. If it is positive clocked, then when the clock will 1, then the output is changed. But if it negative clock is running, then whenever it get the 0 at clock, then the output will toggle. Is it clear now, Srinivas? So in first case, when Q is 1, the Q2 will not work, because this T2 need 0 for working. So first case, the rest of all flip-flop are remain in 0 state. Now is it clear? Now when the second pulse is arrived, second 0 is arrived, what happened? This 1 toggle to 0, this 1 toggle to 0, and this 0 is arrived to the T2. Now T2 work or not? Srinivas, tell me. T2 clock got 0. Now T2 work or not? Work. So now this output 0 is turned to 1. See here. And because of this 1 feeded to the next clock of T3, so this T3 will not work. That is why it is remain in 0. Now in next trigger, what happened? This 1 now, this 0 now converted to 1. That is why this 1 is feeded now here. This portion is not work, because it receive 1. That is why this 1 is remain here. The same 1 is remain here. But this step is changed, toggled. Now again in next trigger, it all are the change, and it will turn in 1 0 0. In that way, the counter is count a bit. Is it clear? Okay. Now see some theory here. The asynchronous counter is a simple and straightforward in operation and construction, and usually records a minimum amount of hardware. In asynchronous counter, each flip-flop is triggered by the previous flip-flop, which is shown here. Each flip-flop is triggered by the previous flip-flop, and hence the speed of the operation is limited, because the first case it is work only, rest of all are not working. And second case, it is work and it is work, the last one is not working. In that way, for getting the whole working the whole flip-flop, it will need minimum 3 or 4. So for that the speed of the operation is very limited for a asynchronous counter. So in fact, the settling time of the counter is cumulative sum of individual settling time of the flip-flop. This type of counter is also called ripple or serial counter. As we know, the problem of asynchronous counter, it need lots of time to perform its tasks. So the speed limitation of asynchronous counter can be overcome by applying clock pulses simultaneously to all the flip-flop, and this causes the settling time of the other flip-flop to be equal to the propagation delay of single flip-flop, and the increase in speed is usually attained at the price of increased hardware. This type of counter is also known as parallel counter or synchronous counter. So what do we do? Now we go for the ripple counter first, which we described here. The same thing what I told. See, the clock pulse is fitted. I think I already discussed this, and how is count, everything is written over here. See, in refill counter, we use the T flip-flop and we know the how it is work. Okay, I already mentioned. See, for count the 0, all the flip-flop are 0. Now first clock pulse is received, then this Q1 is toggled and rest of all are stop. Rest all are stop. Now when the second clock pulse is received, it will toggle to 0 and it will also toggle. But that is stop. And third case, it is toggle, it is not toggle, it is not toggle. And the next case, it is toggle, it is also toggle, it is not, it is also toggle. So in that way the counter count and see the clock pulses. See, every clock pulse Q0 is toggled, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1. And see, every 2 clock pulses, this is toggle. And you see that? And every 4 clock pulses, it is toggled. See the relation. See, for 2 times toggle Q0, Q1 1. Is it clear now? See the truth table. It is very interesting. See the truth table. Every clock pulse received, Q0 is toggling. See, every 2 clock pulses, Q2 is toggling. Every 2 clock pulses, because 1 clock pulse is fixed and second clock pulse it will toggle and it will remain fixed in next clock and again it will toggle. So alternative 2 clock pulses it will toggle. And see the relation of Q2. It will toggle to alternative 4 clock pulses. Am I right? From watching this table, is it understandable? Is it clear? Okay, now see, it is shown here. See, Q0 is toggling every clock pulses. Q1 is toggling every 2 alternative clock pulses. And Q2 is for every 4 clock pulses. So it is the truth table and the clock representation, timing diagram representation of a ripple counter. Is it very hard? Counter is very hard. Good. Now we go for the synchronous counter. As we know, the asynchronous counter problem. What is the problem of asynchronous counter? The main problem of asynchronous counter is that the it has need the lot of time, because one flip-flop's output feed it to the another flip-flop clock. So for functioning the third flip-flop, we need minimum four clock to operate the third flip-flop, because the clock is not getting the synchronous way. See here, because clock is going through like that way, one output is fed to the next clock. So overcome this delay delay problem, you may say, we introduce the synchronous or parallel counter, where see the all clock is fed parallelly. That means every time when one clock is arrived, it will get all the flip-flops. So it will increase the speed or not? Early case universe where the clock is fed to this side, and next flip flop will get the clock from the output of the previous flip flop. See that picture, the chain. The clock is getting from this output. This clock is getting from this output, and without clock the flip flop will not work. So the receiving of clock for this flip flop, that number 3 flip flop, it need minimum 4 clock pulse. So that is why the speed of the operation of asynchronous flip flop is very less. But in case of synchronous flip flop, to overcome this problem, see, we fed the clock to all flip flop parallelly. That means when this flip flop will get zero clock, then all the flip flop will get the 0 clock. So at the same time all the flip flop will work or not? So see, if we think know the timing delay to perform an operation of counter, then we will find each flip-flop has a specific delay time. In repeat counter, these delay times are additive, and the total settling time for the counter is approximately the product of the delay time. That means multiplication of a single flip-flop and the total number of flip-flop. Now if we want to overcome this problem, we need something to do, and the solution is, if all the flip-flop are clocked synchronously, then we can easily overcome the problem. If all the flip-flops of counter are clocked synchronously, then this is known as synchronous counter. Is it clear now? Why it is called synchronous counter? Because all the flip-flop got synchronous clock pulses. Now, how it is work? How it is work? See some additional circuitry here. See, in here, the first flip-flop is fed to the VCC. That means for the first flip-flop got 1, and all input of the flip-flop is getting from previous one, but here we give the additional circuitry because of we need alternative counting. Alternative counting mean 0 0, then 1 0, then 1 1. In that case, see, we not need to toggle that. We want to toggle that only. So if synchronous clock will feed it to all counter, so everyone is toggle every time. If the previous state was 0 0, then the next state all will be 1 1. And the next state all will be 0 0. So we have to overcome this, because we have to count like a sequence. Which sequence? Like that sequence. 0 0 0, then 0 0 1. We have to operate our circuit like this sequence. Now 1 0 0. So we have to maintain this sequence. For that we need additional AND gate of here and AND gate of here. Now when I discuss this, it will clear to you. See, in first case, suppose 1 is here. Now clock pulse is arrived. Everyone get clock pulse. Now first case we reset the all output to 0. Concentrate on cinemas. First case all are 0. Now first clock pulse is hit to every flip flop, but the first flip flop got 1 at T. This 1 is fed to the first flip flop. That means what? This flip flop will toggle. Am I right? And rest of flip flop will toggle or in no change state. Rahul, others flip flop will no change or toggle. See, cinemas, what is the condition of toggling of a T flip flop? The condition is when the T got 1 and clock pulse is arrived, then only output will toggle. Is it clear or not? It is our first condition. Clock pulse is negative. So see, in first flip flop only get T as 1 in T and clock pulse is negative. All others also get the clock pulse negative, but the T is there 0. See, because previous output is 0, so every input got 0. So the rest of flip flop is toggled or not? Except T1, matlab flip flop 1, others are toggle or no toggle. Yes, that means it will remain the no change state. So the output will no change. It remains 0 0. Is it clear? Rahul, is it clear to you? Rahul, are you here? Okay, he may not. Okay, now in this next case, now see the output of first flip flop is 1. That means this 1 also come here. The second flip flop now get 1 also as an input. Am I right now? Now when the next clock pulse is get, then what happen? This output will be toggled to 0 and this output will be toggled to 1. Am I right? Because the both case all are get 1 in input. Am I right now? Okay. Now see, when this output will toggle to 1, now this second flip flop will got 1 because it is toggled. Now this 1 is directly fed to the third flip flop or not? Not, because here we use a AND gate. That means this 1 is fed to this AND gate 1, and what is the output here now? It is toggled to 0. Am I right? Because the second case, it is now turning to the 0. Yeah. Now the output of this AND gate will be 0. Now it is in 0 state, and it is also 0 state. So in next clock pulse, what happen? It is remains 0. And when the next clock pulse is again arrived, see here. Now what happen? This flip flop is now get 0 because here is 0. See. So this T is 0 now. So next clock pulse only this is changed. It is not changed. It is no change state. It is also no change state. Now check. The second flip flop has 1 in output. It come, and first flip flop also 1. So the first flip flop output also come to this AND gate. Now 1 1, it is gate 1. The third flip flop now activate, because the third flip flop get 1. And next clock pulse, the 3 flip flop will toggle togetherly like that way, because 3 flip flop input is 1 now. It is also 1, it is also 1, it is also 1. That is why 3 flip flop togetherly toggled at once. In that way this flip flop will work. Is it clear? You go through this logic, the theory, it will clear. Nothing hard. Rahul, are you here? You are not there, na, Rahul? Wait. Okay, no problem. Just delete everything, neither you cannot understand. Okay, see, concentrate on that. The first case, every Q are 0. That is why all are 0 here. Now, see, the first flip flop get 1 from VCC to the T. So when the clock is arrived to the all flip flop, the only toggling condition satisfied by the first flip flop, because the toggling condition need T is equal to 1 and clock. So this condition will satisfied by only flip flop F1, because the rest of all flip flop got 0 at T and clock is get, but all flip flop has 0 at T. Is it clear, Rahul? Yeah. So that is why the output of the first flip flop will change, will toggled to 0 to 1. So now the second case, the first flip flop will 1 and all the flip flop are no change state because all the flip flop get 0 at t. So those flip flop are not toggled. Now in second flip flop and then second clock pulse. Second clock pulse see the flip flop F1 also got T1 T1 to 1 and also F2 second flip flop T2 will get 1. Am I right, Rahul? Because this 1 is fed to the this T2 and rest of all flip flop got 0. So for next flip flop see the both the flip flop are toggled. This flip flop is toggled 1 to 0 and this flip flop is toggled 0 to 1. Now the rest of all are no change state because those flip flop are not get 1. Now the flip flop of second flip flop output is now 1. But this 1 is not directly fed to the third flip flop. It will fed by a AND gate. And see this 1 is now here. And after changing the second stage, it is now 0. Am I right now? So this 0 is here, then what will be the output of this AND gate? It is 0. And it is also 0 because it is 0 here, so 0 0 0. So in next clock pulse, see what happened. The next clock pulse, we reach this much. Now in next clock pulse, what happened? F1 flip flop 1 got 1, but flip flop 2 got what? 1 or 0? Flip flop 2 0, yeah, and rest of all flip flop also got 0. Am I right now? That is why in next clock pulse see only the first flip flop is toggled and rest are remain the same. What was the previous state 0 0 1? Here also 0 0 1. Only the first flip flop is toggled. Now this is 1. The 1 again come here. 0 to 1. That means in that case now see this was 1 in earlier previous stage. Now this flip flop is turned into 1. So what happened? This 1 is now come here. This 1 also now come here. Now what will be the output of this AND gate? 1. That means this flip flop also got 1 here now. Now the 3 flip flop are got 1 in the input. Flip flop 1, flip flop 2 and flip flop 3. Am I right, Rahul? Now that is why for next clock pulse these 3 flip flop are toggled. See here. The earlier it was 1, now it is 0. Earlier it was 1, now it is 0. Earlier it was 0, now it is 1. These 3 flip flop are toggled. So in that way every clock pulse maintaining this logic we can count a decimal number equivalent in binary. Is it clear now? And it is the operation of a synchronous or parallel counters. Cinemas, is it clear to you? Okay. Now down counter and up counter. We all example we read here, all are the up counter 0 0 to 7. मतलब ascending order. 0, then 1, then 2, then 3, then 4, then 5, then 6. We all are in up process. So that is why it is called up counter. Now if we need the down counter, that means which is count for 7 to 0, then what we need? See, some only we need some modification. What are those? See here, we had the 3 flip flop, 1, 2 and 3. Those all 3 flip flop give VCC in T. Now we feed clock at here. Clock at here. Okay. Now we introduce a logic here like that way for up and down counter. Okay. Now see, we introduce a AND gate here, we introduce a AND gate here. Now what happened? We read here. As we know that in my in up counter, each flip flop is triggered by a normal output of the preceding flip flop. Now whereas in down counter, each flip flop is triggered by an complement output of the preceding flip flop. So if we not introducing this circuitry, suppose we draw a flip flop here. Actually basically that was the up and down. Suppose we need a down counter. If we need suppose this is a T flip flop, this is Q and this is Q bar. Earlier we feed this Q to the T, but in that case we not give, we feed this Q bar to the T. Now check what happened. Sorry, this is not to the T, this should be go for the clock. It is also go to the clock. Now check. We give all T to VCC. That means all T now got 1. Now when the negative clock is received, first we reset all counter to 1. All flip flop are reset to 1. So the first stage is 1 1 1. That means 7. Now when the first clock is hit, it will change to 0. Am I right? It will change to 0. The rest of things are same. Now in next clock pulse what happen? It should be like that: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 0 1, then 1 1 0, then 1 1 1. Now see, from this stage we arrive that stage. The next step will be 1 0 1. That means this flip flop and this flip flop should toggle. So in very next clock pulse, sorry, those are the positive. Okay, sorry, those are the positive clock pulse. Positive clock pulse, not negative clock pulse. So when this Q output is 0, Q bar will be what? 1. Am I right? And this is 0. So is it right? If this Q bar is 0, then Q is 0, then Q bar is 1. So next clock pulse, this flip flop will toggle. See, it is the down counter. Okay. So first stage is 7, the second stage is now 6. Now the next stage, see, this flip flop will get triggered here, and this is positive trigger. That means when the output of Q is 0, then Q bar will be 1. So this 1 is fed to the clock. Very next clock pulse, it will like that, 0 1. And when this output, when the second output goes 0, it is now 1 and it is positive feedback. And very next pulse, what happen? It will turn into there. In that way we downgrade the whole counting. So it is given here to show how the up and down counter can operate by a single selecting switch. It is very easy, nothing else. You just go through that, very easy. Okay. Down counter is clear to all or not?